Hello guys, how are you today? So today I'll be explaining the chemistry quiz, okay? I'm sorry for the late posting because I've been out all day trying to have my vacation. I really apologize if I'm posting late or anything. But anyways, this is part 2 of the chemistry video. The first part was a summary. And let's start. Which of the following are true about chlorine? Chlorine, first of all, at room temperature, it is found as what? It is found as a gas. Now, this gas, it has a choking smell, okay? And it's also a very effective bleaching agent. And one more thing we know about it is that it is a weak acid. So the three options in this one is that it is a very effective bleaching agent, it has a choking smell, and an aqueous solution of chlorine is a weakly acid. Now, it's not colorless unless it is HCl. Okay, so chlorine gas by itself has a color, which is yellowish green, like yellow-green, you know? But all in all, what we need to know in general is that chlorine itself, okay, is what? Is a very effective bleaching agent. It has a choking smell, it is yellowish green, and it is a weakly acid in an aqueous solution. Moving on to question number 2. Chlorine gas, since it is a very effective bleacher, how can we identify it in a lab? It will definitely decolorize. Decolorize means bleaching moist litmus paper. Now to question number 3. Which of the following are true about hydrogen chloride? Now, of course, there is a difference between hydrogen chloride and chlorine gas. So we're gonna say this is something different. Okay, first thing we know is that hydrogen chloride is an acid. So as an acid, it can definitely react with basic metals. It's not a base, so definitely we're not gonna say it is strongly basic. Hydrogen chloride is not chlorine gas, so you cannot say it is a bleaching agent, because it's hydrogen chloride, okay? And since it is a solution, chloride solution, it is a colorless solution, but originally it was what? It was a gas. So it was originally HCl gas, a colorless gas, okay? That's dissolvable in water, and it is an acidic gas, so that means it can react with basic metal oxides. So the only two correct are these two. Now let us move on to number 4. Which of the following are examples of a half reaction? A half reaction means, or let's say it in this way. A half reaction should consist of only these 3 things: the element, the ion of the element, and the electrons. So when you look and you see more than one element, you take it out. You look and you do not see electrons, you take it out. You look and you do not see any ions, you take it out. Because a half reaction consists of the element itself, ions, and the electrons. So if we start with the first one, we have Cu2 plus, this is an ion, 2E minus, this is electron, and then Cu, which is the element. So this is a half reaction. Next one, we have Mg plus O2. Directly you say no, because it has more than one element. Then we have Zn, the element, Zn2 plus, the ion, and 2E minus, the electron. So we choose it. Then we have 2Br minus, the ion, Br2, the element, and 2E plus, the electron. So we also take it. Then we have Cl2, the element, 2E minus, the electron, and 2Cl minus, the ion. We also take it. And then finally we have Cu plus Zn2 plus. We do not take it because it is more than one element. Now here we started with the redox reaction. Consider the following redox reaction: 2Fe3 plus aqueous plus Cu plus aqueous gives us 2Fe2 plus aqueous plus Cu2 plus aqueous. Which of the following is true about the above redox reaction? One thing we need to know is that redox is what? Redox, if you split it in half, it is reduction and oxidation. Okay? Now, we said reduction is the gain of electrons, whereas oxidation is the loss of electrons. And we also said that we call the elements that undergo reduction, we call them the oxidizing agents. And the elements that undergo oxidation, we call them the reducing agents. So now, looking at this equation over here, at this chemical reaction, we have ignore always, whatever you do, always ignore the number of moles and the number of molecules, okay? Only focus on the ions, okay? Always, always, always forget about the number of moles. So originally, we had 3 plus for the F and we had 1 plus for the Cu. Then, in the reactants, after the reaction happened, in the products, what will we get? We have 2 plus in the products and 2 plus again in the products. But look what happened. The 3 plus lost a positive charge. But is it possible to lose a positive charge? No, it's not possible to lose a positive charge. Instead, what happens is that it's gaining a negative charge. So the 3 plus gained a negative charge, so then it became 2 plus. And we said if it gains a negative charge, then we call this a reduction. So the Fe3 plus went into reduction. And we said that if it underwent, or if it goes in the process of reduction, then it is the oxidizing agent. So that means Fe3 plus is what? The oxidizing agent. Now again, if we are going to go back, we are going to see that originally 1 plus, then it became 2 plus. So it probably gained a positive charge. But can we gain a positive charge? No, it's impossible to gain a positive charge. So instead, what happens is that it lost a negative charge. So if it loses a negative charge or it loses an electron, we say that it underwent oxidation. And if it undergoes oxidation, that means it is the reducing agent. So very simply, what we can say is that Fe3 plus is the oxidizing agent and Cu plus is the reducing agent. All right, now we move on to question number 6. They're asking us for the oxidation number of Cl and HClO. What you guys need to know is you need to write the table or have the table memorized. Me, myself, I don't have it memorized, so I'm gonna open it, okay? We have HClO. We know when we are dealing with hydrogen and a non-metal, because Cl is a non-metal, that means the charge of hydrogen is plus 1. And then oxygen, if it is with anything other than peroxides, then its charge is negative 2. So that means it's going to be plus 1 plus the oxidation number of Cl, which we will call X, plus negative 2, which is the oxidation number of O, is equal to the charge. If you look, is there any charge over here? No. Since there isn't any charge, then we are going to put it totally as 0. Then solving it, you're going to bring this to the other side, and then this to the other side, and you're going to get that X is equal to 2 minus 1, so X is equal to 1. So the oxidation number of Cl and HClO is plus 1. Okay, moving on to question number 7. Which of the following are definitions of oxidation and reduction? Remember, in the previous video, I explained 2 different definitions of oxidation and reduction. Oxidation can mean the process in which the number of oxygen increases, or in other terms, the oxidation number increases. So, the process in which the oxidation number of an element increases is called oxidation. However, the process in which the oxidation number of an element decreases is called the reduction. Okay, so think of it in terms of oxygen. Oxidation number is the number of oxygen. So an increase in the number of oxygen is an addition in the number of oxygen. So that means an increase in oxidation number or an addition of oxygen is called oxidation. However, a removal of oxygen or a decrease in oxidation number is called reduction. Question number 8. This we have to memorize it at room temperature. Chlorine is a pale green gas. Bromine is a reddish brown liquid, and iodine is a gray-black solid. Alright, so now we're gonna move on to question number 9. Now we need to find the oxidation number of barium, BAF2. Okay, in BAF2. Very simply, we're gonna open the table again, and we are gonna look and we are gonna see now that fluorine, okay, its oxidation number is -1. But here we have a small trick. What's this trick? We are trying to find the oxidation number of barium, so we're gonna call it X. And then we're gonna add it to the oxidation number of F. But they told us the oxidation number of a singular F is -1. What if we have F2? That means very simply it's 2 times -1. So X plus -2 is equal to the charge, which in this case is 0. So then X is equal to 2. Okay, so please keep in mind the number of moles or the number of molecules, which is the big number over here, we never take it into consideration. The only thing we ever take into consideration is the numbers inside of the compound, like the singular form of the compound. So over here the answer was +2. Now question number 10. The sum of all oxidation numbers in a complex ion, complex or compound ion, is equal to the charge of the ion. Okay, what does this mean? For example, you have HCO3 minus. Okay, to find the oxidation number of, like the sum of all the oxidation numbers, okay, it's gonna be, for example, H. What is the oxidation number of H? Because it is with a non-metal, it is +1. Plus the oxidation number of C that we need to find, we will call it X. In addition to the oxidation number of O. The oxidation number of O in this case is -2, but since we have 3 over here, it's gonna be 3 times -2 is equal to the charge. The charge is -1. So it's gonna be 1 plus X plus -6 is equal to -1. Move it to the other side. X is equal to 6 minus 2, so X is then equal to 4. This is how the oxidation number equations work. Now here in this question, we are going to the halogens, okay, which one can displace which one. So now they're telling us drag and drop the terms below to determine whether each of the following reactions is spontaneous or non-spontaneous. Very simply, what does spontaneous mean? What does non-spontaneous mean? Spontaneous means that it can be displaced. Non-spontaneous means it cannot be displaced, okay? So if you remember the order was F, Cl, Br, I. If you want to remember it, it's Fickel, Brie. Now, definitely looking here, Cl can displace I. So, Cl over here, can it displace I? For sure it can. So that means the first one is spontaneous. The second one, we have iodine. Can it replace the F? Can it displace the F? It cannot. So this is non-spontaneous. The third one, we have bromine. Can it displace Cl? It cannot either. So this is also non-spontaneous. So the reactions in order are spontaneous, non-spontaneous, and non-spontaneous. Moving on to question number 12. We are gonna see which ones undergo a redox reaction and which ones do not undergo a redox reaction. Okay, so let's do it together. Very simply, what's gonna happen is we are gonna find the oxidation number of each and every single element before, and then the oxidation number of each and every single element after. How does it work? Let's separate them into their elements. We have Cu, CO3, then Cu and O, and then C and O2. Now, Cu, okay, it's gonna take the oxidation number of its charge, which is 2 plus. C is gonna be 4 plus, and O3 is gonna be -6. Okay, with practice, it will become easier for you to do. So the first one, I'm gonna do it just really quickly, and then the second one, I will take my time to explain it, and so on, okay? Now, we said the Cu as an element itself, it gets a charge of 2 plus. O as an element itself, it gets a charge of -2. C gets a charge of 4 plus, and then O2 gets a charge of -4. So in total, okay, if we're taking into consideration, Cu, it started with 2 plus, and then it ends with 2 plus. So nothing changed in the Cu. C, it starts with 4 plus, and it ends with 4 plus, so nothing changes. O3, okay, O is distributed, so you have to join them together. It started with -6, it ended with -2, -4, which is then -6. So none of the ions change. There's no oxidation, no reduction. So we say this is a non-redox reaction. Now for the second one, let's say we're gonna take into consideration ZNO. ZNO, we do not know what's the oxidation number of Zn, so let's solve it. Okay, Zn is gonna be X, and we know O is -2. And then it's equal to the charge, which is 0, so X is then equal to 2. So very simply, Zn, its oxidation number is 2. O, its oxidation number is -2. Now, you never take into consideration the the coefficient if you are working on it singularly. What do we mean singularly? Meaning that we are finding the oxidation number of 2HCl by itself. You never take into consideration the coefficient. But however, if you are working in a reaction, you have to take into consideration the coefficient. Okay? So what's gonna happen now is that the H, originally, its ion, or its charge, is gonna be +1. But since there is a big 2 next to it, this means we're going to multiply it by 2. So it becomes 2 times +1, so +2. Cl, originally it was -1, so times 2, it becomes -2. So this is how we ended up. Now we move to the product side. We know Zn, it is going to be 2. Cl, it is originally -1, but since we have a 2 over here, we have to multiply it by 2. So -1 times 2 becomes -2. H2O, originally H, its oxidation number is +1, but because there is a 2 over here, we have to multiply it by 2. So it's gonna be +2. And then O, it is always -2. So looking at it, Zn, it started with 2, it ended with 2. O, it started with -2, it ended with -2. H, it started with +2, it ended with +2. And Cl started with -2, it ended with -2. So since there is no change, we call this a non-redox reaction. Now here is where the fun and nice part comes. Whenever you see 2Cu, stop and think, is this an elementary atom or not? It's definitely an elementary atom because it does not have a charge and it's single by itself, Cu. So that means its original charge is 0. Also O2, its original charge is 0. But then when you move here, it becomes a compound, and the compound has ions that have charges. So then you're going to break it in half, and then you're going to have 2 times Cu. So it's going to be 2 times the original. So Cu is +2, it's going to be 2 times +2. And then here 2 times -2. So in the end, they are gaining charges. So if they are gaining and losing electrons, we call this a reduction and oxidation, or together a redox reaction. So they gained charges, that means this is a redox reaction. Finally, we reached this one over here. Zn has a charge of 0 because it's an elementary atom. And then we have 2 HCl, so this is 2 times positive 1, 2 times negative 1. Then if we do it again, here Zn is gonna gain 2. Cl2 is gonna gain 2 times negative 1, and then H2 is gonna have 0. Now look, Zn started with 0, it ended with positive 2, so it is losing electrons. It is oxidizing, it's experiencing oxidation. H, it started with 2 plus oxidation number, it ended with 0, so it gained electrons. Okay? And then finally, Cl, it started with negative 2, it ended with negative 2. So what we can say here is because there is a change, yani it started with 0 charge and it ended with positive 2. It started with 2 charge, it ended with 0. So actually that means it gained 2 electrons, my bad. So the H2 gained 2 electrons. This is the reduction. So we have oxidation happening, which is Zn, it became Zn2 plus. And then reduction happening, it was H2 plus, it became H2. Then together we call this what? A redox reaction. Now question number 13. We need to find the oxidation number for these elements, or these elements. The oxidation number for N. First thing we're gonna start is N. We do not know it, we're gonna call it X. O2, we know it is 2 times, because we have a 2 over here, times the oxidation number of oxygen, which is negative 2. And it's equal to the charge, which is 0. So X plus negative 4 is equal to 0. So then X is equal to 4. So N is what? Is 4. The oxidation number of N is 4. But pay attention, did they ask for O2 or O? They asked for O. So the oxidation number for O is negative 2. Now, the oxidation number for HClO4. First thing we have H, which is positive 1 always. Cl, we need to find it. We're going to call it X. And then O4, it's going to be negative 2 times 4. So it's going to be 1 plus X plus negative 8 is equal to 0. So X is then equal to 7. Now pay attention. The oxidation number for H was positive 1. So it's going to be 1. Cl, it was 7. And for O, not for O4, they asked for O, it is negative 2. Now we move on to the last one. This one is different. We have Mn. We need to find its oxidation number. We're going to call it X. And then we're going to add it to O4 minus. We know it's 4 times negative 2 is equal to what? To the charge, which is negative 1. So then solving it, it's going to be X plus negative 8 is equal to negative 1. So then X is equal to 7 as well. Okay, so the oxidation number for Mn is 7, whereas the oxidation number for O is always negative 2. Moving on to question number 14. They need us to see which of the following is being oxidized and which is not, being reduced. So looking at it, you have MnO2. Mn, its charge is... Actually, let us solve for the charge of Mn. So here we have X, here we have 2 times negative 2 is equal to 0. So that means X is 4. So the charge of Mn is 4 and for O2 is negative 4. For the 4HCl, we have positive 4 charge, negative 4 charge. Here again, the Mn is going to be 4 and here it's going to be... okay, this is gonna be 2 times negative 1, so negative 2 charge, and this is gonna be 2 charge, and this over here is gonna be 2 times, this is gonna be 4, and -4 charge, and finally this is 0. So you see guys, I can do this easily because I practice a lot. So please practice a lot and you'll be able to get it easily. So if you notice, we started Mn with 4, we ended Mn with 2. So that means it gained electrons. If it's gaining electrons, that means it is being reduced. And then we started Cl with -4 and we ended with -2. So the number is increasing. That means it's losing electrons. Losing electrons means it's being oxidized. Alright, so that means the one that contains chlorine, Cl, is being oxidized. So HCl is being oxidized. Always when we're doing the oxidation reduction, we're talking about reactants. And the one that contains Mn is being reduced. So MnO2 is being reduced. Question number 15. Few drops of AgNO3 are added to Cl. This we know it from before. A white precipitate, AgCl precipitate, forms. Number 16. These are now all memorization. Hydrogen chloride vapors in contact with silver nitrate. So Cl with Ag will produce AgCl, which is a white precipitate. Now this is something to remember. Hydrogen chloride in the presence of a rod dipped in concentrated ammonia produces a thick white fume. So remember, HCl plus ammonia produces a thick white fume. Okay, now here let us see what's happening. Cu, solid. Originally it was neutral. Then it became positive. That means it lost 2 electrons. Losing electrons means it's going oxidized. It's undergoing oxidization, so it is oxidized. Zinc originally was Zn2+. Then it became Zn. So that means it gained 2 electrons. Gaining 2 electrons means it is reduced. So I'm not sure if these spellings are like this, but it's oxidized and reduced. Number 18. Very simply, you have atom. They are the elementary atom. They are not with anything. They are the basic atoms in their elementary state. Try to highlight this. I cannot highlight it, but it's okay. So that means their oxidation number is 0. Always 0 for the elementary states. Okay. Now we are talking about the oxidation number of fluorine. Fluorine, no matter what it is with, its oxidation number is always equal to -1. Alright, so now we move on to question number 20. In all of its compounds, oxygen has an oxidation number of -2, except when it is with fluorine. If you remember the example I gave in the explanation video, OF. If it's with fluorine, then this is -1 charge, and then this will become +1 charge. But I believe in some cases it is 2OF. Sometimes they put it 2OF. So that means it's gonna be 2 plus and 2 minus. So that means with fluorine it's gonna be +2. And then in peroxides it is -1. So remember, oxygen in all its compounds is -2, except when it is with fluorine, it's going to be +2, and then in peroxides, it is -1. Number 21, the element that lost its electron, okay, is Zn, and the number of electrons lost is 2. How did we know? Just looking at the figure, we see that Zn was originally neutral, but then it became Zn2+. So how did it become positive? It definitely lost electrons. So how many electrons did it lose just by looking at the charge? It's 2+, that means it lost 2 electrons. Moving on to question number 22. The element that gained electrons is the element that became negative. So in this case, it is F2. F2 is the element that gained electrons. Then the number of electrons gained. How many electrons did it gain? Coming here, it is 2 minus, so it gained 2 electrons. How many moles of electrons are gained by 1 mole of a species in part A? What are they saying here? They're saying 1 mole of species in part A. So 1 mole of F2. How many electrons it gives us? It gives us 2 electrons. I think this is all logic, so It's very simple. Here, this is something you have to memorize. When you are doing crystallization step, the first thing you're gonna heat it until most of the solvent evaporates. Second thing, you're gonna transfer it to a water bath in an evaporating dish. Third thing, you are gonna heat until all of the solvent evaporates, and then fourth, you're gonna leave it to dry overnight. Number 24, also these are the ions, you should know them. Reddish brown was Fe3+. Green precipitate that does not dissolve in excess base is Fe2+. Blue precipitate is Cu2+. White precipitate that does not form with ammonia but only with NaOH, this is Ca2+. White precipitate that does not redissolve in excess ammonia, this is Al3+. The one that redissolves in excess ammonia is the N2+, and the green precipitate at last is Cr3+. Number 25, you should know fluorine at room temperature is gas, chlorine is gas, bromine is a liquid, and iodine is a solid. Now, the last and final question, they're telling us what happens if you add AgNO3 to fluorine. It will not do anything, there will be no change because it's extremely reactive. Chlorine will form a white precipitate, bromide will form a creamy precipitate, and iodide will form a yellow precipitate. So let's submit and hopefully we do not have any mistakes. And great, we do not have any mistakes. Thank you guys for watching. I hope you understood and have a wonderful day.